Hello students, welcome back. Let's resume our discussion on section 2. Previously, we went through this example problem. Let's do something similar with a little bit different curve. A little bit different function, I mean. Alright, let's begin. Determine the domain and range. Okay, this is a little bit new. What do you mean by domain? Valid x-coordinate values. That's the domain. And the range, valid y-coordinate values. So from this graph, move horizontally, and what part we have the graph and what part we do not have the graph. Can you see? That's going to be the domain. And move vertically, and what part we have graph and what part we do not have graph. Do you see? Well, here are the answers. Domain is -1 to 3. -1 to 3 up to here, we have graph. And between 3 and 5, we see nothing. And 5 to 9, we have graph. Moving horizontally. Range, -2 to +2, we have graph down here. And then we have a gap. 2 to 3, we don't have anything. And 3 to 6, over here, we have graph. Do you see those? Not yet? Alright, this color coding may help you. Horizontally, from -1 to +3, which I just highlighted in blue, let me highlight in green, because this is a little bit greenish. And then from 5 to 9, let me highlight it in red. So this or that. Do you see? This part and that part. And x equals to 3, that's expunged out. So we have to have parentheses and strict inequality. X is equal to 5, that's again expunged out. So we have parentheses here and then strict inequality there. If this had been, say, solid dot, then that should change the bracket. And that should change to semi-inequality. That was domain. Now you can do the same thing with range. Move vertically. Well, here we go. This part down here we have graph, and that part up there we have graph. The green part, start from y equal to -2. Well, that's a part of the graph, and here y equal to 2. That's not part of the graph. It's expunged out, so we have bracket and then parentheses like this. Strict inequality and semi-inequality like that. And then now, the red part, starting from y equal to 3 to y equal to 6. This time, nothing punctured, just touching. So this is part of the graph. That's solid, so that too is part of the graph. So we have brackets either way. So that's how you can see range. That's how you can see domain. Can I put those in same viewing window? No, I can't. Domain, range. Okay, alright, so much for first problem. And then find the average rate of change. Now, if you don't know the average rate of change formula, you can't. So look up the textbook, and where's the average rate of formula problem? It's this one. Average rate of change is, in general, f of b minus f of a over b minus a. The change of function values over the change of x coordinate, or change of y coordinate over change of x coordinate. And then how do you find out the denominator? Change of x coordinate, 9 minus 6, that's easy, that's straightforward. Going from 6 to 9. Now, how about the numerator? Well, f of b minus f of a, so I need f of 9 and f of 6. How do you find f of 9? X equals to 9 is here, and then move vertically to get to the point, and you have to reach which coordinate? Function value is y coordinate, so you have to read the y coordinate. Count. Is it really 6? Now, how about f of 6? Start from x equal to 6 here and move vertically to the part here. That's the point on the graph. And the function value f of 6 is y-coordinate. So tell me the y-coordinate. What is it? That's how you get 6 minus 4 in the numerator, and eventually you get a 2/3. By the way, the average rate of change is slope of this secant line that is cutting through 6 f of 6, 9 f of 9. Rise over run, average rate of change. It changed on the average from here to there. Instantaneously, it may go down and back up, but on the average like this. In the stock market, for example, if you keep long enough, then first you may lose some, but in the end you recover it, kind of like that. Okay, next, solve the inequality f of x is less than -1. That is, find all x values for each x is less than -1. That was a tough one previously, right? F of x is less than -1, so y-coordinate is less than -1. Y equals to -1 is down here, less than -1, so you're looking for only down below. Down below. You're looking for only down below. And then strictly less than -1, so I'm puncturing these two, and that corresponds to the x value between 0 and 2. This kind of shading will help you. Okay, so much for these graph problems. Let me see. Here's another graph problem. This time we have two graphs here. Okay, average rate of change of f, the red graph. Same as before, so I'm going to leave the details to the students here. I mean, same as the previous problem. This one, except we have different numbers and different graphs, so I'll leave that to students. Answer key is available here if you click open. So find the net change. You have to know the term. What do you mean by net change? Average rate of change, I think it is semi-important. Net change, I don't think it is important, but our textbook also discusses it. So it simply says the difference, g of 8 minus g of 4. So all you have to do is to find out g of 8 and g of 4 from the graph and subtract from one from the other. G of 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, x is 8 and then blah, blah, blah. And g of 4, 1, 2, 3, 4. So x is 4 and then blah, blah, blah. Okay, all right. You get g of 8 minus g of 4. Good luck. This time we have some computation. P of x is given as f of x over g of x. Q of x is given by f of x divided by g of x, so product and quotient respectively. So p of 2 minus q of 2, okay. Don't be intimidated. P of 2 minus q of 2, by definition, this is nothing more than f of 2 times g of 2 minus f of 2 over g of 2. So all you have to do is find out those function values from the red graph and the blue graph. And that's about it, isn't it? And remember, always, the function value is y-coordinate. Then you can do this. Find all x values for each f of x is equal to 4. That's the same as, which coordinate is the function value again? Function value is y-coordinate, so y-coordinate is equal to 4. So y equals to 4, where is it? Where is that horizontal line y equals to 4? Okay, I'll stop there, and I'll ask you to find out x value. Find all x values for each g of x is greater than or equal to 3. Okay, forget about the red graph and look at the blue graph. And g of x is equal to 3, so y equal to 3, but greater than that, so above that region. Okay, I'll stop there. I'm gonna ask you to get the rest done. The answer keys are all available here. Okay, alright, so much for those graphs. We have one more problem here. That too belongs to essential topic, the domain of a function. I think I'd better do this in a separate video. So let's stop here and let's meet again, yet again,